solve in a competition, the colors are put together fairly well for you already just by chance, and you can take advantage of that. So, to some extent, Felix's solve was probably a little bit better than average in that it was a little bit shorter or closer to the solution, but not by much, maybe only a couple of turns out of the 60. So,
in every competition, would everybody have the same cube?
The same scramble. You are providing your own Rubik's Cube, but they're all scrambled the exact same way.
Same set.
Yes, exactly. Yep. And they use a computer to generate them, and there's actually an official scrambler setting them up for everybody at the same time.
How can you detect a pattern if you're blindfolded?
That's actually something I'm going to go over in the next part of the talk. For the first part, I just want to do a demo, just so you can. I'm sure you may have heard of this or even seen it before. Tyson Mao, about 2 or 3 years ago, I believe, went on CNN and did an example blindfold solve, and he was at the time one of the top fastest in the world at this. So if you've never seen this before, what's going to happen is I am going to study it first. I have to study at the beginning. After I'm done studying it, I'll then pull down the blindfold, and the actual solution phase is done blindfolded. I can solve. Now, I have to know when I'm done. I basically say I am finished, and I'll go over how you know when you're done a little bit later. But once I say I am done, hopefully the cube will be finished. It isn't always, because you can make a mistake, but again, this is something that I've trained to try to make sure that you can be somewhat accurate, under pressure especially. So I can't guarantee that this will be a solve, but I am going to go ahead and do my best. And I'm going to do this tournament style, because this is how I train, basically. So what happens is this is timed just the same as the other one. The time starts as soon as I see the cube, and then when I'm ready, I pull the blindfold down and solve it. And when I say that I am done and hold it up, that's when the time stops. So everybody ready? Kind of like before, give me a countdown. I'm hoping to do this in just a couple of minutes, so you can kind of see a demo.
All right, 3, 2, 1, start.
Okay. The first part's a little bit boring. I'll try to give you updates about how I'm doing. You can talk amongst yourselves if you want.
What are you looking for? Patterns?
I can't respond back though. I should have said. I'll go over later. I'll go over later what I'm looking for and how this is actually working though.
Oops. All right. A little music could help.
Distract you.
Oh, it's fine. Competitions are quite noisy actually.
He's doing this with a cube that's 3 by 3 by 3, but his world championship winning was actually 5 by 5 by 5.
Hey.
So there's all different sizes of cubes you can get.
So is the 2 by 2 by 2 one easier, or is it just a different strategy?
It's actually, I was talking to him about this, it's actually, the process of it is a little bit more difficult because with the odd numbered sides, you have an anchor on each side. There's that one cube in the middle that doesn't move anywhere, but the even number ones, you don't have that, so the process is like fundamentally different.
Or you did it to 1 by 1 by 1.
Is there a 2 by 2?
Yeah, yeah, you can buy a 2 by 2 by 2.
You can mess that up?
Yeah, and you can buy 4 by 4 by 4s too, and it's just like harder.
Okay. So do you guys know who Uwe Meffert is? My husband collects puzzles, and I thought he made Rubik's puzzles. I didn't realize there was really a Rubik's.
Okay, I'm a little over halfway through. To give you an update, I'm almost done.
Oh, yeah, Chris is up there.
Done.
Holy crap.
There you go. So.
Oh my god.
How long did that take? 2 minutes, 30 seconds.
So, and I'm definitely a little bit nervous, especially with the with the card. So,
How many
yes.
moves was that?
That was probably around 90 turns, so
Did
I'm
you
almost
do them
doubling.
in sequence, or did you have some patterns?
Actually, I'm glad you asked, because that's the next part I'm going to go over, is what exactly happened there. The whole process. I'm going to go through everything here. And so, and actually, that's because one of the things is this is something that you don't see that commonly, and it's very closely related to the memorization aspect. So I know we've got the apocalypse theme going. So the idea being, in the apocalypse, we're obviously going to be short electricity, or very likely, or books might not be around. So it used to be the case that people did have to memorize entire poems, entire works of art, essentially, like written works, the oral tradition. And I'm going to go over a little bit later, kind of what did they do? How did they do that? Because that is very closely related to how you remember a Rubik's Cube as well. So the first thing I want to go over is the solving phase. Now, I'm not going to describe the actual turns I'm doing. That part is kind of related to the patterns I mentioned for speed solving. There are certain patterns you see often enough that you can practice which turns will solve them. That's not my focus. The more focus is how exactly are you solving it? Because when you turn something on the cube, you're affecting a large number of pieces. And especially if you're blindfolded, you can't see what effects you're doing to the cube. So what I'm doing is actually, we're going to start with an example using blocks. So imagine that these are those toy alphabet letter blocks. And you've got, there's one block for the A, there's a block for the B sitting right next to it, a block for the C and the D. And they're arranged in order from A all the way through H. And we're going to mix them up. We're going to actually physically pick up the blocks and move them around and put them in different spots. And they end up like this. So once you're done rearranging them, block E is first, block G is the one next to that, block H, block A, C, D, B, F. So the blocks are all randomly scrambled up. We want to eventually bring them back to the start, but we're going to do this blindfolded. So the idea is to say, okay, well, how would we remember to move the blocks around? It's the exact same idea on the cube, you just use specific patterns or turns to move the blocks around. Versus for actual letter blocks, you just pick them up and move them. So what we do is, I actually don't remember what the blocks look like. And it's the same on the Rubik's Cube. I don't really care where they are right now. I don't care what they look like at this point. I only care what I need to do to put them back in the right spots. And that's what we call cycle notation. Now, our cycle notation is a little bit different from the actual math cycle notation. Generally in math, cycles are read right to left, but you cubers were kind of lazy. We prefer just to read left to right because it's easier to read that way. So we're going to say, okay, this is saying, because there are actually two things we need to think about. This is block E. It's in the very first location. But that actually means that it's the A location. And in the A location is the E block. So we've got two things we always need to think about. Which block is there? And what is that location? What letter is supposed to be there? So this over here is the G block. But it's in the B location. Because eventually we want to have the block that's the B be the second one. Because we want a B right here. This is the H block. But it's in the C location. Because eventually we want to have a C be the third block in. Now, cycles are read like this. The block that's in the A location, we need to send to the E location. And we can tell that because the block in the A location is the letter E. So we want A, B, C, D, E. We want to send that block here. But the block that's in that location is the C block, which we want to go to the C location. So A goes to E, goes to C. This is a set of directions, basically. This is saying nothing about what the blocks look like. It only says these are instructions that I must follow in order to be able to put the blocks in the correct spot. So this says A goes to E. The block that's in the E location goes to the C location. The block in the C location goes to the H location, all the way down, until eventually we get to the D location. When you close off the cycle, close the parentheses, it just means it wraps around. The block in the D location goes all the way back to the A location, which we can see here, A, B, C, D. The block in the D location is the A block, so it's supposed to go back to the start. Now, the next part is this BG. That's what we call a two cycle or a two swap. That just says the block in the B location goes to the G location, which we can see. In the B location, we have the letter G, so we have to send that down. A, B, C, D, E, F, G. That's supposed to go here. And the block in the G location is the actual B block, which we need to send back to the B location. We actually need to swap the B's and the G's. And that's what this two cycle says. B goes to G, G goes back around and swaps with the B. So, yes?
Is the cycle length determined, is it because there are the anchor pieces? Is that what makes the beginning?
Oh, yes, absolutely. The way you know the locations on an actual Rubik's Cube is by those centers. And just so everybody can see, the centers are the middle ones. So the actual locations on the cube, there are 8 of them for the corners. So this is representing a corner scramble. You could know where the A location is by referring to the middle center pieces. So, but at this point, I just want you to understand the basic idea of you're not remembering what the cube looks like. You're remembering a list of instructions that tells you what to do to fix it. So that's really what you're remembering. Now I'm actually going to go through what a solve does. When you solve, you perform what are called 3 cycles. 3 cycles work like this. The block in the A location, you